my presentation follows on the same theme. I'm going to talk a lot about data and how we can use space to drive value from the industry to generate jobs and wealth in Scotland, I think, from the space industry. Data is growing at an exponential rate, the need for data, and some people say that data is the new oil, but I actually heard other people say it's the new water. It's been so essential to our daily lives that we're basically, everything's driven by data, and it's a massive economy that's growing. We need to be aware of this, but for me, I think that if you look at consumers of data, and a good example of this is it was recently, I think about 3 or 4 weeks ago in the news, they were saying that we check our phones in the UK over 1 billion times a day, which is ridiculous. And what's driving us to do that? We're not just seeing if, our mates just text us or what's happening on Facebook, but it's about what's the news, what's the weather doing, just what's it, if you're into stocks, what your stock's doing, just everything. We're driven by data, even if we don't know it. So, and this is going to increase. There's a real thirst for data, and I think this also comes from change. We're being driven. We're growing up in a world where change and the exponential pace of change is actually making us have a thirst for change and a thirst for new things, a thirst to see what's next. And so we're all living in this world, whether we know it or not. So data is having a massive influence in our lives. And the easiest way to capture data is obviously for us in the space, and it's going to be from space, because once you've launched your spacecraft up there, whatever data it's gathering or relaying, you actually almost you can forget about your spacecraft. And there's a lot of talk about unmanned aerial vehicles being used for data and blimps and planes, high altitude planes for providing internet. But really, for me, all these systems they're high maintenance, they need service. They can fall out of the sky and kill someone. And so there's a huge cost that comes with that. With space, you launch your satellite, it's up there, it runs for 3 to 5 years, or maybe longer, and you gather your data. It's a lot easier to do that, and also it's global. It's not local to that area you're trying to service. It's global, so you can serve a global market with that data. It's a really great way of meeting the demands of data in our society. And some examples of this, there's so many different data sets that people could be capturing with spacecraft. And it's not our job, it's not Clyde Space's job to actually say, here's the data that you should be going out and starting a company and providing a service with. But I think there's some really good examples of where we expect, for me, I would expect us to be gathering data and making use of that data to better our lives. One is Earth radiation budget. We've had some discussions with the Met Office in the past, and there's lots of data that they need that they don't have, but they estimate what the Earth radiation budget is because they don't have enough information. And what I'm told by them is that if they could have data sets on a daily basis of the Earth radiation budget, they can improve their forecast models by an order of magnitude. So it's not just a little bit better, it's an order of magnitude better than what we do just now. So climate change models, weather forecasting. But we're not gathering this data because it's just not been a priority for whatever space missions coming up next, that there has been the traditional way of using space and launching spacecraft. Another great example, I think, is tracking planes. When the plane went missing in the Malaysian flight a year or so ago, everyone was thinking, why are we not tracking planes from space? It seems like a really obvious thing to do. Why is that not happening? It's because nobody's invested in that. There isn't a service there that provides that data to whatever company wants it, whether it be kind of local, national air space management or the airlines themselves. There's no data being provided, there's no service there. Nobody's actually launched those spacecraft to monitor that data, which I think is ridiculous. So another great example of a business opportunity for a company to go out there and say, we're going to go and capture that data, you're going to have a service contract and sell that. And then they can track where the planes are across the world. So there's lots of areas of the world we actually don't know where the planes are. If you think about if there's a plane flying over the UK, we've got all the radar, we can monitor where all the planes are, we can manage where all the planes are, and they actually fly a lot closer together. But once they've left that airspace, there's a lot of distance between those planes. They have to take kind of elongated routes, so we use more fuel. And also we don't know where the planes are, just from a safety point of view, so that's not happening. We can solve that problem with space. And also I think another great example is like Google Earth, for instance, you want to see what your house looks like. In some cases, like if I look on Google Earth, I live in a new house. My house isn't on there. It was built like years ago. So a couple of years ago it's finished actually being built, been in for a year. And you're like, well, why is that? I mean, it's like a really, really old data set that they use for that service. But we expect more, we expect better. But the solution for this is the solution to these problems, to gathering this data, is it massive satellites, is it the big satellites? Well, I don't think so. And the reason for this is they're far too expensive. They're very slow, so you have your idea for your service, and then because it's so expensive, you analyse it, and you develop technologies, and you need to get the thing built, you need to raise the finance as well, there's lots of money involved, and that takes time. So before you know it, nearly a decade's passed, and you've still not got that data for your service. Also the technology as well. You're having to rely on technology that's 10 years old, just because the spacecraft's so expensive, not willing to take the risk on the newer technology. How does that perform in space? So we actually know this one performs well, let's use that instead. So you can rely on much older tech. And the amount of money you need is also really significant, so you've got high return on investment requirement there as well, so your data service becomes really expensive, so you're a more challenging environment to actually sell your data. So we think that the solution is small satellites, and it doesn't necessarily have to be CubeSats. CubeSats is a great example of how you can quickly use space for a service, but it could be larger small satellites, or even smaller ones. The reason for this is they are low cost. They're very responsive. You can have a data service in place within 18 months, depending on the application, how complex it is, but 18 months is definitely achievable, which means you can start selling data a lot quicker. You can access higher technologies because the spacecraft are a lot smaller, a lot less expensive to launch. And by using higher tech, you can actually get much larger performance out of that tiny satellite, so you can do more things within a tiny volume. And also, when you're looking at your business model for this, you can say, well, in order for me to launch my 20 satellites into this orbit and start capturing my data, maybe I need less than $20 million or $10 million, which is a lot easier to raise than going out and raising $1 billion. So it's enabling entrepreneurs to go out there and access funds to get their service in place without having to raise this ridiculous amount of money. And because of that, your return on investment model is completely different, so you can offer much cheaper services and completely undercut if they're in a competing market, you can undercut the guys that have been milking the market with their large spacecraft for many years and really change the industry. And by making data more accessible and cheaper, it's more available to more people as well, so you can see that filtering right through into the whole ecosystem. So I put this slide up here. I've got a couple of slides from different market assessments. This shows how the changing nature of small satellites over the last few years, even the last 5-6 years. Mostly, until recently, they've mostly been used for doing technology demonstration, bit of Earth observation and science. But actually, if you look at the trends, very rapidly at the moment, we're seeing a lot more commercial use of small satellites. Most of them are being used for Earth observation, and we had seen a slide earlier saying that the market's going to be worth £2 to £3 billion. Well, they think about half of that is going to be from small satellites. That's an interesting way of looking at the market as well. We need lots of small satellites capturing this type of data. For me, what's interesting about this pie chart is that COM is only 9% of that chart, but whereas typically that's the biggest part of any applications chart for space if you look at the whole market. So I think there's massive opportunity within the COM sector using small satellites in the future. And it doesn't need to be high data rates. I mean, we're talking about broadband from space and like gigabits per second. I actually think that there's a massive market for very low data rate, the Internet of Things, connecting everything together. It can be text message size packets to connect everything together, and there's a huge market opening up there. And low Earth orbit with small satellites is a great way of actually communicating that type of data. Another great metric to see with this market is the fact that there's loads of money being invested in the space industry at the moment. They expect this year to top $10 billion, which is a ridiculous amount of money. If you look, this is from Bloomberg, if you look at the investment we've seen maybe since 1995, it's been pretty much nothing. But in the last 10 years, we've seen significant investment coming into the industry, and that's filtering through into all sorts of areas of industry, whether it be the applications or the upstream spacecraft building as well. So this is stimulating a market, stimulating technology development. The service was data services. And you can see this in the size of the market. The market's growing ridiculous. I'm concentrating upstream. Clyde builds spacecraft and parts of spacecraft, and unlike some new space companies, I don't need ComDev in this, I know the ComDev, but I'm looking at data, and I've seen other Airbus look at data and study, but other companies of similar size to Clyde Space or kind of similar age in the new space area have spun out data services or launch services, as well as trying to make satellites. We're not interested in doing that. Our interest is getting our product right for the people that want to use space to gather their data. We don't want to compete with them. There's no point in us going out and providing EIS data or taking pictures of the Earth. If we were building spacecraft, we want people to buy spacecraft, not to buy our data. So that's our business model, and we've got no plans to change that. So this is a really interesting slide for us because it shows the number of spacecraft that are being launched. So we want to supply as many of these spacecraft as possible. And the very interesting thing about this slide, and it's showing the number of satellites of under 50 kilograms launched per year. You've got, these are all the planned launches, but the actual launches outstrip the planned. There's lots of spacecraft that the people that created this data don't know about. We're actually seeing greater numbers than what we forecast, and that's growing exponentially. A really interesting slide from the small satellite supply. So for Clyde Space, and I think just a little bit of talk about what we do and what we are doing at the moment. We invested very heavily to do UCube1, as mentioned earlier. It was Scotland's first satellite, and we're really proud of the fact that it was the first satellite in Scotland and all that kind of stuff. But we actually didn't do it because we wanted to build Scotland's first satellite. It was just a consequence of the fact that we were doing it. It was so that we could build lots of satellites as a result of investing in that technology development. And these are some examples of the type of spacecraft that we're now working on. There's actually a lot of spacecraft being built in Scotland, and Glasgow in particular, actually, at the moment, between Peter and our good friends at Spire and Clyde Space. I mean, the number's always changing, but I think it's about 60 spacecraft in the next 18 months, which is a ridiculous number. From one satellite a few years ago to over 60 is a real example of how investing in technology-specific product can lead to a massive change. There was no space industry in Glasgow 10 years ago, and now we're one of the leading areas in the world for this technology. So that's a good example. One of the satellites we're working on, Picasso, is an ESA mission, which comes with its overhead, but it's challenging our technology and driving that forward, and we see this as being us taking a step change so that we can service more applications. So we've got some really challenging control requirements. We need to point at the sun as we exit and enter eclipse within half a degree, so that's quite challenging. But also we've got hyperspectral imager on there, which generates 80 megabytes per second of data. You need to actually, what we do is we process that on board and then downlink it. It's really challenging to do that on such a small satellite. But skip this slide because I probably won't have time. This is one of the developers of it, an ADCS system for Picasso. And we've also got commercial drivers. This is a kind of science and commercial. This is a good example of how Earth observation data is not just about pretty pictures. This is an ocean colour monitoring mission. Data is used for science, for monitoring our coastlines and the health of our water, but also can be used for fisheries and like, so if you've got fisheries down the coastline, you can see what the health of the water is, and you can check for algal blooms. You can see where the fish are in the ocean, so you can go and fish that area. There's a real need for this data, and we've had lots of good feedback on this mission. It's actually funded by Gordon Moore, who's the founder of Intel, which is another interesting fact. But we've got, again, pointing challenges with this, but also we need to downlink the data at 40 megabits per second, because we want real-time data. We're capturing data and downlinking at the same time, so that drives a lot of requirements for the satellite. And finally, we have outer net. I didn't talk about the Spire spacecraft, I thought Peter would, but Spire spacecraft are awesome, just to let you know. But the outer net satellite is another great example. It's a really kind of punky business model. It's free data, but it's paid for content, so it's a little bit like Facebook. You know, Facebook's free, but you get paid for ads. So basically, it's going to be downlinking data all the time, which your devices will just capture, and you can access whenever you want wirelessly, but some of it's going to be paid for content. It's a really interesting model, really cheap way of supplying data to areas of the world that don't have that data. It's supported by the UK Space Agency as well, so it's a really cool application. This is our base in Sky Park. This is where we started. We got a Smart Award in 2006 to develop a power system for a CubeSat. And that was one of the first contracts we ever had in this tiny room, the size of a meeting room, a typical meeting room. We got to 4 people in there, and then we had to move because it was too cramped. And now we're in a big, I think, 10,000 square foot unit in Sky Park, which we are already bursting at the seams in at the moment. So it's really, really exciting times. We're up to about 75 staff, and between ourselves and Spire and Sky Park, we're probably about coming on for nearly 150 people working there in space, building satellites and using satellites. So I think, in summary, I think there's a great opportunity for a new wave of space entrepreneurs to use this, ride the crest of this wave that we're on just now for space technology. The pace of change for the technology is going to see even newer, different applications every year as we move forward. We've got a great opportunity in Glasgow to make the most of that and to supply as many of these new ideas as possible. And also to continue to put Glasgow and Scotland on the map for this area, because we want to attract more businesses here. I was delighted when Spire decided to come to Glasgow, because I knew that meant that we're creating a momentum within Glasgow. We know other companies are interested in coming to Glasgow. We've got this potential to have launch from Scotland, which I think, whether it be Glasgow or somewhere else in Scotland, we're going to be attracting well-established companies that do launch, but also new companies to come and not just launch from Scotland, but they build their launch vehicles here. So, I see 10 years from now, Scotland, the number of people working in space in Scotland is going to grow exponentially, and I think it's really exciting. So, let's keep it up.